A farmer has 2,000 yards of fencing to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? So what we should jump out at us here is most. Most sounds like max, maximum. Okay, so this is a very classic quadratic function application type question, the fencing problem, so you're probably going to see this again. So let's draw a picture, because they are telling us it's rectangular. Anytime we can draw a picture, it's usually helpful to us, helps us visualize this. Okay, so we're talking about yards of fencing to enclose the rectangular field. So that means that 2,000 yards is going to go along the perimeter. So we should think perimeter here. And then what we actually want to maximize is the area. Okay, so we know that, let's recall that area of a rectangle is the product of the length and the width. So let's call our width, as it's drawn here, W. So now we have 2,000 yards total for the widths, and we know we have two lengths, two widths and two lengths in a rectangle. So if I start with that 2,000, and I subtract off the two widths, that's what I'll have left for the two lengths. So then if I divide that in half, that'll give me 1,000 minus W. This is going to be our length. So I'll say that again. You have 2,000 yards to start with, so that's going to be used for the entire perimeter of the field. I'm going to call these two widths W. So if I take my 2,000, subtract off the two widths, that'll give me two lengths remaining. So if I divide that by 2, that'll give me the lengths. So my lengths will be 1,000 minus W. Okay, so now let's make our area function. So we'll make a function here, and we know our length and width, the product of length and width, but we only want one variable. We want an area, and then we want to pick one of these variables, and I used W here. So I'm going to write this A as a function of W. So I'm going to find A of W, and we can see our length is 1,000 minus W, and that's times our width, W. So we can multiply this out, 1,000 W minus W squared, and if we want to rewrite it in descending order, that's not a bad idea. So this is our function, our area function, that we want to maximize. Oops, sorry. This is the area function that we want to maximize. Now, we see it's quadratic, degree 2, and the coefficient of the squared term is negative. So we know that that means this is a parabola opening down. So that means that our vertex corresponds to the max of the function, which is what they're asking us to find, the maximum area. So now we just need to find the vertex. So we can first find our W value. So that's going to be negative B over 2A. So in this case, our B is 1,000, so we want the opposite of 1,000 over 2 times A, which is negative 1. So here's mental math. Negative divided by negative is positive. 1,000 divided by 2 will give us 500. So that's our width, and in this problem, width is given in yards. So that means that if the width is 500 yards, that's going to enclose the maximum, the most area. So they want the dimensions, 2 dimensions, length and width. So there's our width. Now we can just fill in to find our length. So we know our length is 1,000 minus W. So we want 1,000 minus 500, which will give us 500, and this is our length. And that's yards. So that fencing, that field, 500 yards by 500 yards, will give us the maximum area.